Earth's present climate is primarily due to several natural events that have occurred over the past 4.5 million years. One of these events is the closing of the Isthmus of Panama, joining North and South America together. When this happened, it changed the circulation in the Atlantic Ocean, adversely affecting the Gulf Stream. This caused substantial cooling in the North Atlantic and eventually resulted in the Greenland ice cap. But the primary driver of Earth's present climate has been repeating cycles in the Earth's orbit. These cycles involve deviations in the eccentricity of the Earth's orbit around the Sun, the angle of the Earth's axis towards the Sun, and the precession of that axis around its rotation point. These astronomical changes, when combined, are called Milankovitch cycles, which determine the amount of solar radiation falling on the Earth from year to year. These Milankovitch cycles often reinforce each other and cause great deviation in the amount of solar radiation falling on the Earth, especially in the northern and southern high latitudes around 65 degrees. These deviations can cause great changes in the Earth's temperature. We're currently viewing the third panel in our climate model. We're sitting back in time around 5.5 million years ago, and what I'm going to do is translate time from right to left. We're going from the past more into the present. And I want you to notice two things: how the temperature changes here versus the age here. As we start out, note that on average Earth's temperature is running 3 to 5 degrees warmer than the present temperature. So I'll start moving us along the timeline, and we start advancing forward in time. There are a lot of deviations in temperature year to year, and that has to do with the fact that there is currently an Antarctic ice cap, and there are a lot of glaciers in the southern hemisphere, and those glaciers are constantly growing and retreating, and that's causing the Earth's temperature to rise and fall. Here we've reached a period of time approximately 4.5 million years ago. And note that this is when the gap at the Isthmus of Panama, which separates the Atlantic and Pacific Oceans, or North and South America. This is the point in time when that gap in the oceans begins to close up. And once it closes up, it's going to adversely affect the Gulf Stream. And the Gulf Stream will change the circulation in the northern Atlantic Ocean. And that will bring about dramatic changes in temperature in the high northern latitudes, because there's so much land up there. Those changes in the Atlantic circulation is going to bring a lot of snowfall up in this area. And that's going to start creating the Greenland ice cap. So we'll continue our travel forward in time. It takes about 1.5 million years for the Isthmus of Panama to completely close up and separate the two. And shortly after that happens, which will be about 2.8 million years in the past. But shortly after that happens, you'll see that the Greenland ice cap is formed for the first time. And that's going to happen right here at around 2.8 million years ago. We now have ice caps on both poles. The South Pole has the Antarctic ice cap. The North Pole has the Greenland ice cap. Also note that after the Greenland ice cap formed, Earth's temperature finally dropped down to where it's close on average to what we have today. But as we move forward in time towards the present, the average temperature, which is deviating up and down quite a bit again due to Milankovitch cycles or changes in Earth's orbit, the temperature of the Earth is dropping now below today's average. So it's going to be averaging out to be about 3 to 4 degrees below the current value. And we'll continue going on forward in time until we reach the end of this panel and the beginning of the second panel in this climate project. Here we reach the start of the time along our second panel. We're back in time now at about 1 million years ago. We're going to continue our walk forward in time. Notice that the Milankovitch cycles have become further apart. That's because before about 1 million years ago the cycles were happening on a 41,000-year cycle. Now they're going to be occurring between now and present time at around 100,000-year cycle. And if you'll notice, when we start this time travel here, temperature is still averaging below today's value, somewhere around 3 degrees below present, and we're going to go ahead and start our time travel. Notice the wide swings. The peaks of these cycles are called interglacials. That's when the glaciers have retreated the most. And when the dips are at their lowest, the glaciers are at their greatest advancement. I'm going to go ahead and stop along this last peak we get to here right about here. Now this period of time here around 120,000 years ago was the most previous interglacial period. That's when the glaciers in the northern hemisphere had retreated their most. Notice how warm it is. It's running maybe 2.5–3 degrees warmer than today. Also note that during the cold periods the temperature was running somewhere around 8 degrees colder than today. So not only did the cycle spread out here, but the magnitude of the cycles became larger. And that's because during this period of time this was primarily due to the eccentricity of Earth's orbit around the Sun. I'll also take this opportunity to point out that there's a sea level curve here. And at this point in time during the last interglacial, the sea level was running almost 8 meters higher than it is today. So today the Earth's present climate, we're in an interglacial now, but in the last one about 120,000 years ago, and not only was the temperature 3 degrees warmer, but sea levels were running about 8 meters or 26 feet higher than they are today. From here we'll begin advancing in time until we reach the greatest extent of glacial advance, which is where the temperature will be coldest, and we come up against the beginning of the next panel. So here we go. Here we've reached the point in time when we've just gone past the point of last glacial maximum that actually occurred about 22,000 years ago. We're sitting at about 20,000 years ago here. And if you look at the temperature curve, you'll see that we're running close to 5 degrees below our current temperature, which is up here at 0. And I'm going to also point out the sea level here is running over 120 meters below today's value, and 120 meters is 393 feet. Now from here, as we slowly walk forward in time, we're going to be leaving the last glacial maximum. And we'll start approaching our current interglacial, which is this period of time. And again we are valuing the current temperature, which is averaging 57 degrees around the Earth. We're valuing that it's 0 here, and the numbers you see here are showing us differences above or below today's average. So we're going to go ahead and start walking in time. Note that temperature is coming up, and so is sea level. Sea level rises, of course, caused by glaciers melting mostly in the northern hemisphere, but really all over the world. And will continue to go forward in time. And here somewhere around 11,000 years ago, note that we reach our current average temperature. Sea level though is still running about 60 meters or almost 200 feet lower than today, and it's going to take several more thousand years for sea level to get up to about where it is today. Specifically, sea level today is only 8 inches higher than it was in 1900, and our temperature today is only 1 degree higher than our historical average, which was measured between 1960 and 1990. So we'll continue walking forward in time until we reach the present temperature and sea level here.